Hello. This is going to be the first update video for the game and game engine. We are working on a game called Survive, which is basically a first-person shooter that is also it's a first-person zombie survival shooter in a procedural open world. It's kind of a mouthful, but it's a lot of things. Right now this is just an engine. It might not look like much, but it is mostly all rendering work and then integrated bullet physics. This video as the second video. I didn't really narrate the first video, but in this video it's improved rendering, like the lighting and specular highlights are significantly better. And what else? Oh yeah. These models are loaded from a different file format, loaded from a collada model file, which is more advanced and it has a bunch more features. And basically I switched model formats to eventually load animation, which will probably be not in the next update, but the one after it. If you look at the lighting without, this is without lighting or any sort of shading, it's just a basic model with the texture, which just looks really dull when you compare it to the final output with all the shading. You can see how the shading makes all the details really pop out. It really does make a significant difference before and after lighting. It kind of makes it all the work I've been doing on the rendering for the last few weeks worth it when you see the before and after. There are a few problems with the rendering, but I think it's good enough now where I can start working on more gameplay specific stuff like weapons, shooting, world generation, zombie AI, all the fun stuff really. Okay, now I'm just going to go through the basic components that change this to this. First we have just the basic normals, which are the direction. All these different polygons is just only their direction. And then that's used for primitive lighting. And then to make it more detailed, you add the normal maps, which add almost all the detail for the lighting. It just adds all the intricate stitching and all that stuff. After that, the specular highlights, and this is the specular map, which is used to get the highlights. This basically just shows what parts of the model are the shiniest. So like the belt buckle is shiny, these rings are shiny. So the wider it is, the more shiny it will be, like the hair and all this stuff. Alright, and then those maps are used to generate these specular highlights, which are the actual highlights, which are basically just highlights based on the direction of the camera and the direction of the light that sort of make it look shiny. And then that is combined with the final lighting, which comes from the normal maps, and then the direction of this sunlight, which can move, as you've seen before. So those two are combined to create basically the final scene, with a few other maps that are in here. Okay, the next map is the opacity map, which is this. It basically shows what part of the hair is transparent, so the black is invisible and the white is solid hair. You can see how it looks like before and after. So the hair is invisible there. Okay, the next map is the subsurface scattering maps, which I don't use right now, but will be used for improve the skin rendering. And it uses these maps to render the skin in a more realistic quality. And the Joker's is purple, obviously, because it's a purplish tint to his skin. Now the final map is this tint map, which can be used for a lot of things in the engine. you can use one model and have a bunch of different colors for the same model. So this just shows what part of this model will have its color changed based by the shader. So I can stop rendering that. If I go into the shader, I can change the color from just red, which it is now, to just green. Save that and then load it in the engine, and now the shit's green. You can change it to something else. That can be used to tint stuff from like cars, zombies, houses. So I can have a bunch of the similar models and then tint them different colors to create a lot of different variation without having to use too much memory. So that's how we get from this very dull, simple rendering to a more realistic, high quality rendering. The last map I forgot to mention were these self-illumination maps. Basically they show parts on models like here on Batman and here on this big red guy that are supposed to emit light. So if lava's on this guy's back, then obviously it's going to emit light and brighten up other parts of his body. And then if you look at it, you can see it better without the color. Just glows around when it's added to the character. And then if it doesn't care about the light because it's light itself. So if I rotate the sun, as you can see, it's very primitive sun system, where just basically this cube is the light volume and it rotates around. It'll be better, the sun system will be better and then later, but for now it's just a quick test. But you can see in the dark, these self-emission or self-illumination maps still emit light and they glow in the dark. That's it for this update. Right now I'm working on terrain, so this box that everything's laying on will be replaced by multi-textured terrain system, which is almost finished. Then after the terrain's done, which it's pretty close to being done, I'll post a video about that. And then I'll start working on the animation. And that's it. So thanks for watching. You can follow the development of this open world zombie survival shooter at subsurfacegames.com.